All right, so this is, finally, we're in lesson 5.2. We made it out of 5.1, but we have to remember everything that was in 5.1. And we're going to be verifying trig identities. And that's going to be our directions on every one of these, is just to verify. All right, so for the first one, we're going to have cosine squared of beta minus sine squared of beta equals 1 minus 2 sine squared of beta. Well, don't let beta make you nervous. It's just a Greek letter, just like theta and alpha and omega. It just kind of looks like a bee with a tail. All right, and this is one of those ones, it's kind of difficult to decide which side is more complicated and which side is less complicated. Bless you. So I'm going to say that the left side is the more complicated side, because this one, you have two different trig functions. This one has a 1, so it's slightly less complicated. Now, we are only going to work on all of these. We're only going to work on one side. So don't ever do something to both sides of the equation. So just leave one side alone and make the other side look exactly like it. All right, so if you look at what we want to end up with, it only has sine. So obviously, we need to make the cosine squared somehow turn into sine. So look over at your identities. What can we do using an identity to change cosine squared into something with a sine? Preferably a sine squared. Yeah, we're going to use number 9. And if we solve number 9 for cosine squared, it's going to be 1 minus sine squared. So what we'll do is go back up in the problem, and where we had cosine squared of beta, we're going to change that to 1 minus sine squared of beta. All right, and I just keep bringing the other side down until both of my sides look the same. All right, so now I'm going to combine like terms. So what do you guys think you get when you combine negative sine squared of beta minus sine squared of beta? Negative 2 sine squared beta. And once you get the left side to look exactly like the right side, you have verified it. So we're done. Any questions on that one? Okay, let's look at another one. So for B, we have a fraction on the left. The numerator is sine of x plus cosecant of y. And then the denominator is sine of x cosecant of y. Right? And then that's going to equal sine of y plus cosecant of x. All right, so this one is kind of obvious which side's more complicated. The side with the big old fraction is more complicated. So this is what we're going to do with your list of things. We're going to do number 5, which is if you have a polynomial over a single term, you can split it into several fractions. So it's not technically a polynomial because we have trig functions in it, but we have addition in the numerator and no addition in the denominator. We can do this with subtraction also. If you have addition or subtraction and no addition or subtraction in the denominator, you can split this into 2 fractions. So what we would do is take sine of x first and write it over your denominator. All right, and then whatever sign you have in between your terms, In the numerator, that's what you put in between your fractions. All right, and then we would do the same thing with cosecant of y. Whoops. And then I'll just bring down my right side. All right, so looking at that first fraction, what can we do? Say it again? Yeah, we can eliminate a sign of x. So if the whole numerator is canceled, what's up there? A 1. All right, and then for our second fraction, we can do that with the cosecant of y. Okay, so I'm just going to rewrite what I have after reducing. So what is 1 over cosecant of y? Sine of y. It's just reciprocal, same thing here. 1 over sine of x, we're going to get cosecant of x, and that is exactly what I wanted. Now I know a lot of people don't like it when the variable is not x, and people have asked me, like, can I just always write x? And I probably told you no, because of problems like this. It's important, like we can't write those both with x's because it just won't work out. So just go ahead and use the variables in the problem. All right, y'all okay? We're gonna do one more. All right, so for C, we have the quantity 1 plus cotangent squared of x times the quantity 1 minus sine squared of x. And eventually, we need to get that down to cotangent squared of x. Now, sometimes when we have these problems, you are going to multiply. And if we did it on this problem, it wouldn't help us. It wouldn't be wrong. It just wouldn't lead to the answer, I don't think. Or if it did, it would take a long time to get there. So I'm hoping when you guys see the squared trig functions and plus 1 and minus 1 or 1 minus, that you look at your Pythagorean identities. So what does 1 plus cotangent squared equal? Cosecant squared. All right. And what about 1 minus sine squared? Cosine squared of x. Okay. So it already looks a little bit better. Okay. Any ideas on something we can do so just to lead us into getting cotangent squared? Yes, good. We're going to take cosecant squared and use the reciprocal identity. So what we're doing right now technically is what number 7 says, to convert everything to sines and cosines. So when I say everything, I don't mean what's on the right side, because that we can't change. But everything on the left side, I can write using sine or cosine. All right, so cosecant squared is 1 over sine squared. Cosine squared we're going to leave alone because it's already written as cosine. Okay, and then when I multiply that, if you need to, you can put cosine squared of x over 1. If you don't need to, it's fine. But we multiply across the numerator and across the denominator. And then that is one of your quotient identities. So remember, the quotient identities work for powers. So we end up with cotangent squared equals cotangent squared of x. So on these problems, you do have to show me every little step. It's kind of like writing an English paper. You can't just go straight to the last sentence, first sentence and last sentence. You have to do all the stuff in between, because all the stuff in between is you verifying it. All right, any questions?